Good morning students, my name is Vora, Assistant Professor of Electrical Department at Sri Swaminarayan Institute of Technology. So we are already start the chapter number 1, the automatic generations and the voltage controls. तो स्टार्ट विद द न्यू टॉपिक हम देखेंगे लास्ट लेक्चर्स में हमने क्या देखा था. सो इन द लास्ट लेक्चर्स वी आर सी द फ्लैट कंट्रोल्स ट्वाइलाइन बेस्ड control and the method of voltage controls. So frequency control system or flat frequency control system is nothing but we can connect the two systems with the parallel systems. So in this method the major generator having the longer generator capacity have even the job to maintain the system frequency. यानी कि हम जब दो सिस्टम पैरेलली कनेक्ट करते हैं तो उसकी कैपेसिटी, फ्रीक्वेंसीज, वोल्टेज, करंट और सब कुछ सेम रखते हैं. सो दिस मेथड इज़ यूज्ड व्हेन द स्मॉल सिस्टम एंड द लार्ज सिस्टम आर interconnected through the tie lines. So the tie line is nothing but the connections between the two systems. So the large system maintain the system frequency contained while the same system is controlled to keep the tie line power constant. So this method is not suitable when the two or more large systems are interconnected. So each area control should have on generation to supply the change in the load in that area. Then during the normal condition it should supply the power to the others. Then after that during the normal conditions it should change the generations. Sometimes it should help to maintain the stability of the systems. So here there are the four different areas and this one is connected of the two areas with the tie lines. If the fault in any area, for example the area 2 will be faulted at that time, this one is connected with the A1 and area A3 and they have to connected two tie lines. So the frequency or the voltage is given to these tie lines. So tie line based control system is the extended power supply can be divided into the number of load frequency control area interconnected by means of their tie lines in order. So these are the two control areas, control A and control B, and these two areas is connected with the tie lines. So to get the commercial benefits from the neighboring the systems, then to meet the sudden requirement of the electrical powers and the improve the reliability. It means अगर सडनली कहीं पे जो हमने आगे एक एग्जांपल देखा जो 4 एरियाज़ है उसमें सडनली कोई एरिया में ज़्यादा इलेक्ट्रिक पावर की रिक्वायरमेंट रहती है तो दूसरे एरिया से जहाँ पे कम होता है वो से ट्रांसफ़र हम कर सकते हैं. एंड द लास्ट वन इज़ द रिड्यूस इन द इंस्टॉल द कैपेसिटी. इट मीन्स कि अगर वो फेल हो जाता है, हमारी जो सिस्टम है फेल हो जाती है तो उसको वापस से इंस्टॉल करना और रिड्यूस करने के लिए यानी कि उसका पावर वापस से रनिंग में लाने के लिए हम ये सिस्टम टाई लाइन बेस्ड कंट्रोल सिस्टम यूज़ करते हैं जिसको हम ग्रिड भी कहते हैं. सो एडवांटेजेस फॉर दिस सिस्टम इज़ टू इम्प्रूव द परफॉर्मेंस ऑफ द जनरेटर्स. लोअर इंस्टॉल कैपेसिटी इज़ नीडेड बाय रिड्यूसिंग द रिक्वायर्ड ऑफ द reserve capacities. Then lower capacity cost, improvement in the reliability. What is the disadvantage? So the switch gear perform get the affected by the faults, then need the large break of the circuit breaker results. Then proper management is needed. Now this one is connected for the local load changes. So the regulators have their desired control from the local loads and they benefit to response the change in the remote areas, and this type of controllers allows the tie line schedules to the device from the normal value into the adjustable proportions of to the frequency device from the rate values. So here the graph of the systems. Now the non-local load changes. So in these controllers are placed in the both the areas where the control actions is needed to done and the non-local load changes will not act if the slope of the controller character is same. So there are the three types of control characteristics: flat tie lines controllers, then flat frequency controllers, and the tie line based controllers. So tie line based system is the connected for the universals and non-local changes. Then after the voltage control, so the voltage variations is the delta V across the transmission lines can be given as delta V is equal to P into R plus Q into R upon V, where the delta V is the change in the voltage, P and Q is the active and reactive power of the generators, X and R is the resistance and the reactance of the transmission lines connected to the generators. So in the general voltage control equipments are placed at the generating station, transformer stations, and near the transmissions and the distribution feeders. So the method of the voltage control is excitation control method, then step changing transformer method, induction regulator method, then synchronous condenser method, EGC systems, automatic gear controllers, then automatic voltage controller, series and shunt capacitors, and the last one is the voltage control by the flex devices. So we can see in the last lecture is the excitation control method. When the load on the supply system change, the terminal voltage of the alternator is changed. So they have the two main type, the trill regulators and the Borville regulators. The trill regulators, in this type of regulator is nothing but the constant value resistance is cutting in the cutout of the field circuits of the alternator by using the top changers. So the major parts of the regulators, you can see here the method of the voltage control systems. Generally the relay contact is open. When the fault is arise at that time, the relay will be energized and the relay contact will be closed. To set the rheostat values at that time, this one is released. Then after the Borville regulators, in this method the field rheostat resistance vary the continuously or in the step, and the variance in the alternator voltage is sensed by this control device which control the motors. So you can see here there are the two windings, the main windings, and another one is the auxiliary windings. Auxiliary winding have the divided by the two parts, and we can see variation in the regulators. So in the last lectures we can see this. Then after see the tap changing transformer. So tap changing transformer is again nothing but the regulators. So excitation control method is used for the small length transmission line but not for the long transmission line. So the tap changing transformer method have the off-load tap changing and on-load tap changing systems, and the auto transformer system and booster transformer. The off-load tap changing is nothing but when the load is not connected to the supply, at that time we can change the transformer systems. On-load tap changing is during the supply system is connected, at that time we can change the tap changing of the transformers. Auto transformer which have the only one winding, and they are perform the primary and secondary in both. And then after the booster transformers. So these are the tap off-load tap changing. Then on-load tap changing transformer, you can see that this one is the on-load tap changing transformers. Alternator transformers, these are also called the variac, we know in the variac, and booster transformers. So in the last lecture we can see these two methods. Now today's topic is the method of voltage control and the voltage control by the flex devices. So we know that we can already see the excitation control method and tap changing transformer method. Now the inductions regulators method, synchronous condenser method, AGC method, automatic voltage control, series and shunt capacitors, and voltage control by the fact devices. So now the inductions regulators. So inductions regulators have the one winding is moved with respect to the other winding depending on the flux cutoff. Secondary voltage values is varying. So the primary winding is connected in the parallel with the supply and the secondary winding is connected to in series with the transmission lines. There have the two different type of inductions regulators. So when the primary winding is changed with the others, the secondary voltage is injected to the line also change, and there are the two types of inductions regulator. The first one is the single phase inductions regulators and another one is the three phase inductions regulators. You can see here we get the regulate of these here put in the single phase systems, and here the rotor phase winding, this one is the stator windings. Now then after we can study about the synchronous condenser. So synchronous condenser is nothing but the synchronous motor is used as the synchronous condenser, and this synchronous motor provide the leading kilowatt ampere power to the transmission lines, which is source of the lagging of the kilowatt transmissions power. So the synchronous condenser is name is given to the synchronous machines that is connected into the electrical network to help in maintain the system voltage, and the synchronous machines in this case is essentially a motor to which is no load is connected. So here you can see that the synchronous condenser system. So the synchronous condenser is the more advanced technique of the improving the power factor that the static capacitor band, but the power factor improved by the synchronous condenser is below the 500 kVA is not economical than that by the static capacitor band. Now then after the study of the automatic generating systems, so AGC system for the automatic generations control in the interconnected power system, that the AGC is divided in the load among the system stations and the generators so as to get the maximum efficiency with less cost, and the control the schedules of the inherence of tie line power maintaining the uniform frequencies. So in the electrical power system, the AGC is the system for the adjusting the power output of the multiple generators at a different power plant and in the response to change in the loads. So since the power grid required that the generations and the load closely balance moment by the moment and the frequency adjust to the power of the generation are necessary. So जो हमारा जो पूरा पावर सिस्टम है जहाँ से हम लोड जनरेट से करके डिस्ट्रीब्यूशंस करते हैं उसका पूरी कंट्रोल सिस्टम की बात यहाँ पे हो रही है. सो यू कैन सी हियर्स द कंट्रोल द एक्साइटेशन सिस्टम. हम जिस तरह से आउटपुट चाहते हैं उस टाइप का हम यहाँ से एक्साइटेशन जनरेटिंग सिस्टम देंगे. So these are the all the automatic generating systems. So the functions of the AGC system is it is balance the generations and the load in the power systems. Then after it is used for the frequency controls to minimize the frequency deviations and the regulates the tie line power flow. Its system is the control actions are initiated at the load dissipated center from the each control area in the power systems. Now study the automatic voltage control or the automatic voltage regulator. So automatic control voltage regulator is the generated voltage depends on the rotating speed and the excitation current of the generators. So in the EVR system of the voltage is controlled by the excitation current keeping the speed constant, and this is called the voltage control system or excitations. So the exciters is the main component in the EVR loops and it delivers the DC power to the generator field. It must have the adequate power capacity and the sufficient speed of the response. So these are the EVA system to continuously check the stator rotations. So the basic role of the EVR is to provide the constantly of the generator terminal voltage during the normal and the slow change in the voltage. So depending on the types of the supply given to the field winding of the alternators. So exciter is classified as the DC exciter, AC exciter and the static exciters. So the block diagram, you can see here the block diagram of the generator voltage control system is, so this one is the systems given to the amplifiers, then after the DC exciter, then generators. This one is continuously checked to the rectifiers, and the stabilization we can put in the DC exciter and the generator. We know that how it is work. So the generator terminal voltage is connected with the set of the reference voltage to get the voltage error signals. So this signal is given to the voltage regulator. So this regulator output is given to the block of the transformer functions is KE upon the 1.TS. So the exciter output is given to the field winding which adjusts the generator terminal voltage. So now you can see that the basic block diagram of this system. This one is the amplifiers, exciters, exciter stabilizations, then generator field. Now the last method of the voltage control system is the series and the shunt capacitors. So now we can talk about the shunt capacitors. The shunt capacitors are used to improve the power factors. It applies the proper amount of the reactive power to maintain the proper voltage. So it is used to improve the power factors. So the capacitors are mainly connected to the bus bar and the placed along the transmission lines to maintain the load and the voltage drops. So the capacitors are mainly connected to the bus bar. So the capacitor is the constant impedance type of load, and its values is the proportional to the square of the supply system voltage. So therefore the voltage falls. अगर voltage falls होता है, so the VAR system produced by the shunt capacitance falls, and thus we can need the most their effect of falls. So here you can see that when in the shunt capacitance, here you can see the block diagram of the single line diagram of the transmission line and its voltage phasor diagram before the additions of the shunt capacitance and after the additions of the shunt capacitors. So here you can see that the diagram of the without the capacitors, the voltage of the current and the VR you can see here, and after the current we add the capacitance of the systems. Then after the series capacitors, so as we know that the capacitor are connected in the series with the transmission line, conductors, and they are used to reduce the inductive reactance between the supply points and the load. So the capacitors are connected in series, and one disadvantage of the series capacitor is that the high voltage are produced when the short circuit current flow through it. So these are the phasor diagram with the connections of the capacitors, series capacitors. Now the next one is the voltage control FACT devices. The FACT devices is the different connections of the device. So they have their 4 FACT devices: the static VAR compensators, then thyristor control compensators, static synchronous compensator, which one is called the STATCOMs, and the last one is the unified power flow controllers, UPFCs. So in this topic we can learn the static VAR compensators. So as we already study up, the static VAR compensator is a set of the electrical device for providing the FACT acting reactive power on the high voltage electricity transmissions networks. So these compensators are provide the fast reactive power to transmissions of the networks, and this method makes the power system to operate the unity power factors by automatic machine matching the impedance. So the static VAR compensators are placed to solve the large power system problems like the power transfer capacity of the transmission systems, then transient stability limits of the power systems, then damping of the power oscillation, then temporary voltage over voltage of transmission systems, damping of the subsynchronous oscillations. So in the industries, the SVC are placed near to the high and the rapid varying loads, such as the arc furnace, where the absorbed by the SVC reduce the voltage filters, and the temporary over voltage are absorbed by the SVC to get the voltage control of the systems. So the typical SVC consists of the transient control reactors, TCR, where the reactor may be air or iron cooled, then thyristor switching capacitors, TSC, then after the harmonic filters, mechanically switched capacitors or the reactors. So this one you can see here the thyristor values we can put the system. This one is the TCR, thyristor control reactor systems. This one is the thyristor control capacitor systems. So these two systems are having the shunt connected reactor control using two parallel and represent the connected of the thyristors. So the TCR control the reactive power by changing the current magnitude passing through the reactor or reactors, and this one is without the firing angle controlling using the step changing reactor options. In the second one, the capacitor's operation practically is the same time of the same as the resistor control, but the reactor is replaced by the capacitor. For the reactor calculate, we have to consider the fully connections or the fully disconnected of the capacitors. So these are the different type of considerations. This one is the mechanically switched reactors, this one is the TCR system, TSC system, harmonic filters, here LC filter will be used, and mechanically switched capacitors. So these are the different type of the constructions of the SVC systems. Now we can talk about the mathematical models. So mathematical model is the used to control the voltage of the bus by controlling its equipment resistance. So basically it consists of the fixed capacitors and the thyristor control reactors. So there are the two types of the SVC controls, the SVC total susceptance models and the SVC firing models. So now first one is the SVC structures. So SVC structures is nothing but the total suspected models. They have to changing the susceptance, it means the B, and the fundamental frequency equivalent susceptance of all the shunt modules making up of the system. So you can see the figures of the systems. So here we can reduce the susceptance, total susceptance, we can use the impedance system, and to maintain the power we can use the capacitors. Then after the VC total susceptance model, so the equipment reactance which depends on the changing of the thyristor firing angles and is made up of the parallel constructions of the thyristors control reactors. This one is equivalent admittance and the fixed capacitor is react. You can see here we can use the variable thyristor controls. So you can see the last figure of the steady state and the dynamic voltage control characteristic of the SVC. So within the control range, the current and susceptance and the reactive power is C hang to the control voltage according to the slope characteristic. So this one is called the slope characteristics. So the slope values depends on the depending of the voltage regulators and the desired sharing of the reactive power produced between the various sources of the systems. So the slope is typically 2.5 to 6.5% at the capacitive limits, and the SVC becomes the shunt capacitors. So at the inductive limits you can see that the shunt reactors. So these are the dynamic characteristic and these are the static capacitor characteristics, because you can here the minimum value we can put the capacitors and the maximum for the inductors. So today we can see that the different type of the voltage control methods and see the voltage control by using the FACT devices, and in the particular FACT devices we can use the static var compensator. If any questions regarding this topic you can contact me. If any questions regarding this topic you can mail me. My mail ID and the contact number is in your screen. Thank you.